Well, good morning, everybody. Welcome. My name is Nate Schutta. I hail from the great state of Minnesota, so I just want to say it is delightful to see like blue sky and lack of snow. We actually had a major snowstorm about 2 weeks ago, which means there actually still is snow on the ground, which is not normal for Minnesota this time of year, but I have to say I'm very happy to be somewhere where there is no snow, no hint of snow. There was never snow. That just makes me very, very giddy. Well, let's talk about this cloud thing, shall we? If you look at the cloud, it's pretty quick to realize there's a lot of options here. There's a lot of different ways we can approach the cloud. Everybody has a different definition of what we even mean by cloud. You know, some people assume that, well, if you're doing cloud, you've got to be doing microservices. And other people are like, oh, no, we're doing modular monoliths because that sounds like more fun. I run into a lot of people who are very, very excited about containers. Everything's got to be in Docker. And generally when I ask, well, why Docker? They say, well, because Docker. You know, I see that a lot in our space. You know, we need to use this technology, and you ask someone why, and then they just repeat the name of the technology back to you over and over again. And of course, now we've even started to move beyond that. Now we're going to serverless, because you know servers were so last week. We don't need those anymore. And people are getting into functions, and let's just write a little function to do some work for us. And of course, we have to put as a service at the end of everything now. And then this gets into this whole conversation about, well, am I cloud native? Is this cloud native? What does it mean to be cloud native? How do I be more cloud native or cloud native plus plus or something? And how do I make sense of all these buzzwords? You know, our industry is really good at inventing new terms. So first and foremost, I think it's important to ask, well, what do we even mean by cloud native? You know, and in a nutshell, I would say it's just an application that's been designed to take advantage of cloud computing. This has got a lot more to do with how we create and deploy applications than anything else. There's some very fascinating abilities that come along with cloud computing. You know, some of the things that I'm sure you've all taken advantage of is the fact that I can scale up, I can scale down, I can do that all on demand. You know, think about how we used to have to do this 15 years ago. Beginning of a project, someone would ask you, well, how much capacity do you need? And of course, this is the point in the project where you know the least, and you're being asked to come up with the answer to that question. And so what do? We come up with a big guess, and then we double it, and then we'd add a little more, hopefully, because it's really hard to get more capacity. So we'd want to have all this excess capacity just hanging around in case we needed it, which means that for many of our organizations, our actual server utilization was a low single-digit number. Now, many people are very excited about the cloud because it's limitless compute. Now, of course, there's a big asterisk at the end of that, isn't there? Additional fees may apply. You know, yeah, you can keep scaling things out, but eventually your CFO is going to come and have a conversation with you about the bill they just got from their provider. Now, this is more than just an architectural pattern. Quite frankly, it's this combination of practices, techniques, technologies. You know, generally, this is some flavor of agile development. You know, we're probably going to do some continuous delivery. There's going to be some significant automation involved in order for us to do this at scale, do this quickly, scale up, scale down, et cetera. Yes, there are probably going to be some containers in here somewhere. The interesting question is, are we responsible for maintaining that container, or is someone else? And yeah, there's probably going to be some microservices. We could have a fun debate about what it even means to be a microservice. Maybe we're going to have functions instead. That's fine. But a lot of people ignore a really important part of this change, which is the effect it has on our culture. Culture is where good ideas go to die in most organizations. The culture of your organization gets set very, very early on in the tenure of your company, and it's really difficult to change. Now, in order to do this effectively, we need to have some amount of DevOps. And what's been really interesting for me is to see this massive shift in infrastructure over the last 10, 15, 20 years of my career. You know, this has kind of started gradually, but I remember when our servers were all homegrown. They were bespoke, they were artisanal. We would literally order the parts, put them together ourselves. We spent all this time, effort, and energy handcrafting these servers. And not surprisingly, we treated them like pets. For example, these are my pets. The little one in the front, his name is Han. You can probably guess what the name of the one in the back is. It's Chewy. And I assure you that my family would make me spend an inordinate amount of money keeping these two things happy and healthy because they're our pets, they're members of the family. And so these homegrown, bespoke, artisanal servers, well, we do the same thing. we would spend countless hours updating and patching and making sure that they were at their best capacity. And of course, when we needed to deploy these things, we realized very quickly that, man, that's a heavily constrained resource, isn't it? Because those servers were expensive. You guys remember how expensive servers used to be? I mean, it was ridiculous. We'd need to raise millions and millions of dollars in funding just to get some servers purchased. And so our accounting side of the house said, hey guys, you got to take advantage of that. We got to get a return on that investment. And thus was born the app server. Because the app server fundamentally allowed us to put a whole bunch of apps on that one heavily constrained resource, thus maximizing our return on investment. Everybody wins. Except there was a really big unintended side effect of being on shared hardware. These shared resources meant that one application could take down another application. I have seen this happen. I had an application, one of mine about 3 years ago, went down on a random Monday morning because over the weekend, somebody changed the MIME types on the server. 9 out of 10 apps went down. The 10th app, the one that needed that new MIME type, it was fine. Now, I don't understand how we didn't notice this in dev or in test or in staging or any of the other environments we had, but we didn't. It only happened in production, wasn't that fun. I've seen all sorts of pain around coordinating changes. I had one application years ago. I wanted to be on our new strategic single sign-on solution. I was told, great, you can have that. It's going to be available in May. And I thought, that's awesome. I want to go to production in June. This couldn't be better. Except I needed to also then get my application onto the latest instance of the server software, the latest gold image. And of course, that meant I had to get into a whole nother queue. And I thought, okay, well, I'm at the head of that queue, so now I can have it, right? Oh, no, we're not changing anything on any image until the entire pool of servers has been upgraded. So you can't have the single sign-on solution until May of next year. So my poor application had to sit on a tactical solution for almost a year and a half because we had to coordinate changes with literally hundreds of other applications. And this is why throughout my career at least, I have spent a significant amount of effort. I mean, I don't even want to imagine how many years I've actually spent on currency issues. And every time there is a currency push, we need to get all our servers on a new version of this, it basically amounts to an 18-month period of, I'm sorry, no one can change anything. We're going to do zero development work. Sorry, poor business people, you can't get any new features yet. And everybody gets very frustrated because there's all sorts of testing headaches, and then things break in random ways. Which is why for so many of us, we just kind of kick currency down the road. The pain wasn't worth it. This was just too difficult. We'll let it be someone else's problem. I think that's a pretty common pattern for us, right? It's like, just kick it down the street, and by then I'll be promoted out of this position, or I'll be at a different company. It'll be somebody else's problem, not mine. Now, when I've thought about this experience, I channeled my inner Yoda, and I remember this famous quote, right? Fear is the path to the dark side. Fear leads to anger. Anger leads to hate. Hate leads to suffering. I mean, who knew we had Yoda ops? But this is the world we lived in. It was too scary. And think about what we've traditionally done. We've taken our code and we've moved it from one instance of an app server sitting on one piece of hardware to another instance of hopefully that same app server, but on a completely different piece of hardware, which inevitably meant it worked in dev, but not in test. How many of us have experienced that wonderful problem? Yeah, a friend of mine, this was so common in his company, he had little stickers made up that said, works on my box. And if you dared to utter that phrase, he'd slap one of those on your laptop. It was not a badge of honor, right? And so we take a step back and we pound our head against the table and we're like, why didn't this work? It worked here, but not there. And you're looking at it and you're like, well, the environments are the same. The worst example I've ever personally experienced, we went through this process. It worked in this region, not in that region. We're going through every possibility. Everything's identical. Oh, well, it turns out the patches were applied in a different order on one of the servers. So even though they're all at the same patch level, order of operations mattered. And so it didn't work in one region, it did in the other. I mean, that's really where you start to say, can I do something else for a living? There has to be a better way to make a living than this. I mean, do plumbers deal with this? Do electricians deal with this? I mean, seriously, there's got to be another option. But now we've started to see this shift. And now as we look around, we realize that these servers are actually commodities. We're not using this custom silicon, this custom operating system. We're using commodity parts. We're using Linux. We're using Intel chips. You guys have probably all seen that little stick figure cartoon. It's like a dad stick figure and a child stick figure, and the child stick figure says, "Hey, Dad, what are clouds made of?" And the dad responds, "Mostly Linux servers." Right? I mean, there's a lot of truth to that. And not surprisingly, by moving away from these specialty products, our prices have dropped. And all of a sudden we look around and we realize, hey, you know, the server's not actually our constraining resource anymore. It's us. It's the people cost of this whole thing. And so now we've seen this whole new generation of options spring up for us. We've got Heroku, we've got AWS, App Engine, Cloud Foundry, Azure. By the way, Redis fits in every one of those buckets. And all of a sudden we realize that, hey, these shared servers are actually a liability now. That if I'm on the same hardware with somebody else and we're using the same app server, well, that's now a downside. That's not winning. And we've started to change our approach to these servers. We don't treat them like pets anymore. We treat them like cows. If you're on a farm and your cow gets sick, you don't have the vet come out and spend thousands of dollars making the cow healthy. You put the cow down and you get a new cow. We generally don't name cows, we give them a number. And so if number 15 gets sick, we go get a new instance of number 15. That's not entirely true. I grew up on a hobby farm, and we had Texas Longhorns. We had about 24 of them at various points over my youth. And one day, we had one cow, we named her Houdini, because she somehow knew how to get in and out of the pens at will. And so one day I was sitting in my living room, and you know, I kind of feel like there's something looking over your shoulder, and I glanced, and here's this 300-pound calf on the porch just kind of looking at me, wagging her tail, you know, say, hey, what's going on in there? She was like a dog. I mean, she ended up growing into this, you know, half-a-ton dog. She'd come up to you, you'd scratch her ears, and she'd kind of moo at you. It was very cute, but that's the exception, not the rule. And so nowadays, we have this whole new set of abstractions that we can rely on that free us from a lot of the pain that we've had in the past. And so now instead of having this instance of a server that I deploy code to, we're going to use containers or platforms so that now, instead of it being my code that's moving from one instance to another, I'm going to package everything together, everything it needs, the app server, all the environment variables, blah, blah, blah. And that's the thing I'm going to move from one environment to another. Now I have consistency. This is a huge win for us. So now if it works in dev, it's going to work in test because it's the exact same thing. And in fact, let's be honest, we're not really moving anything generally. We're just changing some rules in a routing table to say, hey, no, this URL now points here instead of there. So we don't have to worry about physically moving anything. This is a huge win for us. The other side of this that I don't think gets enough attention is the fact that this frees us up from lowest common denominator development. You know, think about how many times in large enterprise organizations you've been stuck on a certain version of Java or C# or whatever language of choice is because, well, I'm sorry, not all of our applications are ready to move to the new version. And so your application can't take advantage of that fancy new version yet. Well, in this kind of an environment, you go ahead and define whatever you need. You want to be on Java 1.6, knock yourself out. You want to get on the latest and greatest bits, go for it. You need to be on that spiffy new version of whatever library, you're free to do that. It doesn't impact my application. We're all isolated. Now, I have had some prod ops people push back on me at this point and say, but Nate, you're duplicating resources. That same jar is going to be in multiple app instances. And so this is where I kind of sigh heavily and I sort of metaphorically reach into my pocket and hand them a couple singles and say, see here, this will cover the cost of that duplicated jar. And by the way, that frees me from a whole class of problems I don't have to deal with anymore. That is so much win. The other side of this, though, that I think is very, very important for us to consider is where's the value line for us as developers? What do we get credit for? I mean, let's be honest. Currency is important. It matters. I mean, Equifax. Everybody knows Equifax now because of currency. But let's be honest. Our business partners don't ever care about that. We don't get cookies for that. They don't make us a cake because, hey, look, we upgraded from version X to version X+1, aren't you happy? They care about features, they care about functionality. And so this work, while important, is quite frankly undifferentiated heavy lifting for us. We want to get out of the business of that. We want to be doing as much as possible work that our customers value and say, hey, that actually hits the bottom line. Thank you so much for that. By the way, we baked you a cake. What we're striving for ultimately is the Anzi haiku, which says, here is my source code. Run it on the cloud for me. I do not care how. That's the ultimate goal. Take my code and execute it on my behalf. Figure it out. And of course, this has a huge impact on how we do development. Because now we truly can embody that always be changing code. Because we can. You know, I still think one of the most powerful aspects of this is the fact that changes are so much less risky than they were before. I mean, think about typical release weekend. We're overlaying existing code. If it doesn't work, can we even get back to where we were before? And the answer generally was no, not without some serious pain. But this environment allows us to say, all right, spring up a new app instance that has the new code in it, and I can route just a percentage of my traffic to the new thing. And I can monitor and I can see how it works. And if everything is good, I can crank up the volume a bit and put 20% or 30% of traffic. And if it turns out that something slipped through testing, no problem. Change the routing rules back to the old instance, and I'm right back where I was before, which means I can do changes pretty much all the time. I mean, why do we have like release weekends? Because we don't want to impact customers, so we try to find a period, typically very late at night on the weekend when, I don't know about you guys, but I'd much rather be sleeping. And what do? We all sit in a war room with our fingers crossed, drinking a whole bunch of caffeine, hoping everything works, knowing in our hearts that something is going to blow up. But this environment allows us to experiment. It allows us to do A/B testing. To me, this is another really powerful aspect of this. You've all gotten into a debate with somebody on your team about the impact of a certain change. If we do this, sales will go up. If we do this, conversions will go up. If we do this, whatever metric makes sense in your world. And we all were just speculating, right? But in this environment, I can actually run that experiment. I can deploy it, and I can put 10% of my traffic on it, and I can get real numbers. And now we can adjust to real numbers as opposed to arguing over, well, I don't know, I think this is probably what will happen. We can be far more responsive to our business partners. This is huge. I mean, think about a typical application where we're like, okay, well, this will be done in 18 months, which really means 36. That's when you'll start to get value out of this, sorry. And so this environment allows us to deliver in days, not months. You know, one of the most powerful aspects of this, for me at least, is seeing these older companies, these big enterprise companies adopting these kinds of approaches that are far more common in the startup space. And what was a real eye-opener for me at Spring One this year was to see a gentleman get up from Scotiabank and say, hey, we used to do 4 releases a year, now we do 3,000 a month. And it's like, wow, that's a big shift. Now, they don't get there overnight. There's engineering effort that takes to get there. But to me, this was a real eye-opener because I had friends in my old organization who were out at this conference and they were talking to me. They're like, oh, Nate, this is great stuff, but we can't ever do this. And I called BS on that. I said, this is a big legacy company. If they can do it, you can too. Because let's be honest, in today's environment, speed matters. Disruption is everywhere. And I know it's an overused term, but every industry is being impacted by this. I mean, just think about Amazon buying Whole Foods. That was a shot across the bow. I mean, how many grocery store chains consider themselves technology companies, except now Amazon owns Whole Foods? So now overnight, you're a grocery store chain, and all of a sudden you're like, wow, Amazon's our competitor. I mean, let's be honest, Amazon's coming for all our lunch money. My previous employer, I worked at an insurance company for a long time, we absolutely viewed Google as a competitor. Now, that wasn't day one. That took some time for people to realize that that was a possibility. But let's be honest, we're all technology companies today, whether that's convenient or not. Now, I heard 12 factors mentioned this morning during the keynote. Imagine that. Everything's about 12 factors now. You've probably at some point seen the 12-factor app list. And all it really is, guys, is a bunch of characteristics that our successful apps seem to share, at least from Heroku's point of view. And I think you're probably familiar with many of these. I would argue most of these are just good design practices, period, whether or not you're worried about deploying to the public cloud or on-prem or anything like that. But, I mean, please tell me version control isn't controversial. I mean, everybody's using version control, right? I mean, you're all using Git, or you're probably using Git, or you might be using Git, but you're using version control under the covers somewhere. Defining our dependencies, we got to know what we depend on. Dependencies are hard. There's no getting around that, but obviously pretty important we get that right. We need our configuration separated out from our code because this is going to be deployed into different environments. We can't have something hard-coded sitting in our code base. That's been very common throughout our history. You accidentally leave a credential hiding in there or a password, something like that. We got to treat all our backing services as an attached resource, allowing us to easily plug in and plug out different things. We want this very stable build, release, run life cycle. Now, one of the harder things is to get to this stateless model. If we're truly going to do this, we can't be sharing things. We can't rely on writing something out to the file system and then hoping it's there the next time we come back, because the next time we come back, it's going to be something totally different. It might be a very different instance that we respond to. And we're going to use port bindings for service export. We're going to scale via process. So lots of little things instead of we'll just get bigger hardware. Start up fast, shut down fast. This is really important from a health check perspective. The routers that sit in front of our application say, hey, I have a problem. I need to spin up a new app instance. Well, you haven't responded yet. You must not be healthy. I'm going to start a new instance. And it just keeps doing that until you run out of quota. This one's near and dear to my heart, but I want parity between dev and prod. I don't want to be in a situation where, well, it works here, but it doesn't work there. I've wasted too much of my life dealing with those kind of issues. We need our logs to be event streams now. I can't just write to the file system and then just go to that server and go to that location on the file system, because it might not be there the next time I come back. And we want to run all our admin tasks, these little one-off processes. Now, I'll be honest with you, if you've got legacy applications, and I know you do, you're going to violate some of these factors. That's okay. That doesn't mean you're a bad developer. We could not have predicted this 10 years ago. There's no way. By the way, if you could have designed an application 10 years ago that happened to be all 12 factors compliant, I'd like to have a conversation with you about maybe some stock ideas or who's going to win the next Super Bowl. I think we could make some money here. Now, there is a possibility, although it's highly unlikely, your legacy app might actually violate all 12 of them. That's pretty rare in my experience. In general, the ones that I see violated most often are defining your dependencies. This one's hard because let's be honest, how many times you get your application up and running and you look around, you're like, do we really need this library? And everyone says, don't touch it, it works. Leave it alone. Right? Let's not go through the pain of pulling it out and then discovering there's this weird little whack-a-mole problem that shows up a month later. Separating out your configuration from the code. Again, a lot of us over the years have inadvertently hard-coded a credential. Maybe we hard-coded a database connection. So we need to have the mantra that says, I can open source this application tomorrow if I want to. Not to say that we will, but just to have that as a goal, and usually that helps us stay a little cleaner with that. Share nothing. Again, this one is hard. I've had a lot of applications in my career that were designed with a specific page flow in mind. You started on the search page, you searched for something, and then you went to page 2, and then you went to page 3. And along the way, we just got in this habit of, we'll just throw it in session, it'll be fine, we can just pull it out of session the next time. And that worked in an environment where I was always coming back to that same server. And of course, session replication, all sorts of other fun problems cropped up along with it. Start fast, shut down fast. This is really important. I've had a lot of applications in my career that take minutes to start up. Why? Because we go to the database and we pull in a whole bunch of stuff into memory so that it's faster. Go get me the states, go get me countries, go get me region codes, go get me business codes. All this kind of stuff doesn't change. Load it into memory so it's fast. The right answer, of course, now is to use a distributed cache. We'll talk about that here in a second. And of course, I can't do this because now my health checks aren't going to work. So we got to make sure that these things spin up and spin down quickly. Dev prod parity, again, this is another one that's traditionally been challenging. I'm amazed at how many developers build their applications on one operating system. Even if they're using an app server, it's running on a different operating system than the one they're going to run in production. And then we wonder why things aren't consistent between the two. No one could have predicted this. So we want consistency. We need consistency because that shortens our code to prod lifecycle. That's a really good mental exercise to do. How long would it take in your organization to take a one-line change from customer wants this change to that code is running in production? What is that measured in? Days, weeks, months? I've seen it all. But we need to avoid this, it worked in test, but not in insert region X here. Now, I've had some arguments with developers about the 12 factors, and I've had some people say, well, my application has to be 12-factor compliant. I have to comply with every single one of them in order to be cloud native, right, or to even move to the cloud. No, you don't. I mean, that's a great goal. That's an awesome thing to strive for, so please do. But we need to be ruthlessly pragmatic in our environments. Now, obviously, some of these are more important than others. There are certain things, if we don't fix that in our application, we're not getting the full benefit out of the cloud. So if I have long startup time, well, geez, that's going to make it difficult for me to self-heal. That's going to make it difficult for me to scale on demand. That's a problem. So that's probably one we need to worry about. But a lot of these other ones, we can sort of put a little further down the path and say, we'll get to that when we have time. honestly, guys, this is a continuum. This is the way I think about it. So if we sort of have 12 factors compliance across the bottom, we get more benefits the further to the right we go down that path. But we still get plenty of benefits even if we're a quarter of the way, halfway, 3/4 of the way down that road. I worked at a big enterprise company for a good chunk of my career. We did this analysis through about 400 applications in my line and tried to kind of rank them in terms of some are good candidates, some are meh candidates, and some are bad candidates. And there was a small subset that weren't candidates at all because they violated something that we couldn't fix. They had a dependency on a third party, that vendor thing that just didn't have a cloud component at all. But we strive to figure out, well, let's try to do as many of the good and meh candidates as possible. And we eventually figured out after doing some pilots that we can generally get these things up and running anywhere from 2 weeks to 2 months, depending on how many of the factors they violate. And we actually had rough numbers for each factor as far as how long does it take to fix that. That's an important thing to do in a legacy code base, is to make sure you know what do we want to move, what makes sense to move, how long is it going to take us to move those things. Now, you will hear people talk about 15-factor apps. You'll hear people talk about beyond the 12-factor. And you know what? However you define it, I don't think matters. What we're trying to do is maximize the benefits the cloud gives us. And to do that, we really need to make sure applications are designed to take advantage of what the cloud gives us. So yes, your legacy applications will fall short. That's okay. Opportunistically refactor them. If you're building new today, please go cloud native. I strongly advise you not to build legacy code now. Well, let's talk about microservices, shall we? I can't swing a dry erase marker without hitting someone doing microservices. And let's be honest, this is a reaction to monoliths. This is a reaction to the heavyweight SOA environment some of us worked in maybe a decade or so ago, combined with the things the cloud gives us. Now, let's be honest, monoliths hurt. Developer productivity is painful. What's the longest developer startup you've ever experienced? And how many of you have had like the developer started guide that's like 90 pages long? Right? It's a lot of fun, isn't it? It's really hard to get your head wrapped around a massive, massive code base. And so that poor new developer comes along and it takes weeks or months or even a year before that person's productive in our environment. And that's no fun for that person. It's no fun for us either. So what we're trying to do today is say, well, are there some things we can do to make this better? And how do we get away from the past where, geez, if I wanted to make this one small change, it meant I had to deploy the whole darn thing together, and that was risky. And well, if I need to scale up, I got to scale the whole darn thing up as well, even though there's a whole bunch of the application that doesn't need that extra hardware. I couldn't just scale up the piece that needed the extra scalability, the extra capacity. Turns out monoliths can be really, really hard to evolve. I'm sure you've all at some point in your education run into the second law of thermodynamics. I refer to it as a teenager's bedroom. And that basically just says the universe wants to be disordered. Now, our software is not immune from the second law of thermodynamics. I'm sorry. You've all had that new project and you're all very excited and we're like, we're going to do it right this time. We're going to have good, clean modules. And then it breaks down. It inevitably breaks down. Maybe because we had to jam some features in to meet an important demo, or the intern did something crazy and we haven't had a chance to go fix it, or we did a release and bad things happened, so we had to monkey patch some stuff over the top of it. And eventually we discovered that this impacts our ability to add new functionality. And so out of this frustration came this sort of new microservice style, and we now refer to it as a microservice. Now understand there is no one true definition of microservice. This very much fits into the eye of the beholder. So the guy that runs my group, Andrew Clay Schaefer, tweeted this out a few years ago, but I think it's very apt. Who wants to argue about the definitions of made-up words with me? I mean, this is software engineering in a nutshell right here. I mean, how many times have we had a knockdown, drag-out argument over the definition of a made-up word? I mean, I love the fact that, a lot of us use spring, and we talk about spring, and our customers are like, oh, you mean the season? And we're like, the what? We don't even think about that. Now, my personal favorite is anything that can be rewritten in 2 weeks or less, because that reminds us these are supposed to be small, that if we decide to blow this away and start over, we're not like, oh my God, this is an impossibly large task. You hear a lot of people refer to this as a two-pizza team problem. I don't love that definition simply because, well, how big's the pizza and how hungry are my developers? This doesn't necessarily match up one-to-one. But I think it ignores a more important characteristic here, which is how many microservices should my two-pizza team be responsible for? Is it 5? Is it 10? Is it 20? I mean, this is a real question. My director asked me when we were starting to do this in my last organization, he's like, Nate, how many microservices can my team support? And of course, I kind of had to shrug and say, well, it depends. Now, a lot of this depends on how volatile those services are. If these services are constantly changing, my two-pizza team might only be able to handle 4, 5, or 6. If they don't change that much, well, maybe I can handle 10 or 20 or 30. I don't know. The one thing I'll say about how you define a microservice is make sure within your team, within your organization, you agree as to what that definition should be. That's more important than whether it's the platonic ideal or whether it's the definition I would use. You want to be on the same page with your coworkers so that when you say, we're building a new microservice, everybody understands what that means. I would argue it's more important to think about these in terms of characteristics. So I look at microservices as a suite of small, focused services. Do one thing, do it well. This should sound very familiar to anyone in this room who's ever worked on Linux or Unix because it's small tools that you pipe together to get more complicated results. These things should be independently deployable. They should be independently scalable. I'm amazed how many times I work with people that are like, oh yeah, when we change this microservice, all 7 services get deployed together. When we scale this microservice, all 7 microservices get scaled up. And I look at them, I'm like, why? And they say, well, because they have to. It's like, I don't mean to be the one that calls your baby ugly, but that's not a microservice now. That's more of a monolithy-like thing. And that's okay. There's nothing wrong with a modular monolith. But we're not getting the benefit for that thing being a microservice if I have to deploy them together. I want these things to be able to evolve at different rates. I want to be able to choose the right technology to solve this problem. I don't want to have to be lowest common denominator because we're a Java shop or a C# shop or a Ruby shop or whatever. If Java is the right choice for this, I want to use Java. If Python is the right choice, I want to use Python. We can build these things around business capabilities. And fundamentally, guys, you know what this boils down to? It's what I consider the 0th law of computer science, the 0th law of software engineering. It's all about high cohesion, low coupling. The longer I do this, the more convinced I am that that's the core of almost everything we're trying to do right here. Go read the Gang of 4 Patterns book and figure out how many of those are an implementation detail of this at a different level of abstraction. So that's all microservices are in my mind, is applying high cohesion, low coupling to services. Now, at the end of the day, guys, it's just an approach. It's just a style. It's just a pattern. It is not, in fact, a golden hammer. I'm sorry about that. You know, of course, you got to be worthy to lift this one, so maybe that's why we're having problems. I don't know. And a lot of us, of course, look at these things as the solution. This is the panacea. This is finally the thing that's going to cure cancer and be better than sliced bread. I hate to burst your bubble, but these are just tools. It's all these things are. Microservices, all these things, it's just a pattern for us to apply. The challenge for us, the art in what we do, is figuring out when to pick up which tool. You know, if you had a carpenter come out to your house to do some work, and that person showed up and they had one hammer, and they said, this is the hammer I use for everything, you'd probably ask that person to leave. If you have anybody in your life that's into woodworking, you know there's probably 19 different hammers that to your eye all look the same. This happened. I was over at a friend's house out in his beautiful woodworking garage, and I'm like, what's the difference between these hammers? And it was basically, well, this one's for walnut and this one's for oak. I mean, it wasn't quite like that, but that's the way I interpreted it. So the challenge for us is to use those wisely, or as I like to say, please microservice responsibly. Now, my friend Simon Brown has a great way of phrasing this too. He says, you know what, if you can't build a monolith, what makes you think microservices are somehow going to solve all your problems? And let's be honest, sometimes the right answer really is a modular monolith. So how does Redis fit into this picture? Well, quite frankly, it's sort of the Swiss Army knife in this architectural pattern. You know, and I think a lot of us traditionally kind of look at Redis and we say, well, it's a cache, right? That's all you can use it for is a cache. And it's like, no, it's actually quite a bit more than that. You could have it for all sorts of different meals. You know, it is more than just a cache. I mean, you look at a typical sort of pattern, you look at all the different kinds of use cases you can slot Redis into, it's kind of crazy, all the different places that it can fit in our world. Many of the problems that we just talked about can be ameliorated by using Redis in some way, shape, or form. That's pretty fascinating. So we talked about session management. Well, we could use Redis for storing session. Obviously, we can use it as a caching server. This was one of the big things that we did at my last organization to get over our long startup times and say, well, we need a distributed cache. Well, what do we have? Well, we have Redis. Let's use Redis. So now we don't have to pull all that stuff into memory because we can do what we should have done in the first place, which is just use a caching server. You see some people using it as a search engine. You see some people doing it for time series database, for analytics, as a message broker. And what's fascinating is to see how much of this boils down to speed. And that's an important consideration for all of us. We want this stuff to be snappy. And so when you actually look at what kind of use cases are people trying to solve with it, a lot of times it's all about how do we go faster? We need this thing to go faster. We need better response time, less latency, et cetera, et cetera. So what can we do to increase our speed in our applications? That's an important part of this. So when you think about some of the top use cases for where Redis pops up in our world, again, it's session store, it's caching, it's these sort of translytics concepts, it's API rate limiting, being able to use it for message broker or queue, blogging. Imagine that. Tags, we still do tags. That's a really important thing, isn't it? Tags kind of change your mind in a lot of ways. Remember when we had to put everything in folders? And you always had to have that debate with yourself. Does it go in this folder or that folder? And then you'd try to search for it, and you'd always find the wrong one because and you wouldn't be consistent. I was never consistent with folders. With tags, just keep throwing more tags at it. What's the worst thing that can happen? Seems like most of our applications now devolve to some version of instant messaging or email, spreadsheets. Are you online or off? How many followers do you have? What kind of friends do you have in common? How about user comments or ratings? And I know I've never worked in the gaming industry, but certainly there are some interesting uses here in peer-to-peer games or leaderboards. We'll talk about that one in a minute here. So I can actually manage my session stores using Redis hash. Now, if you think about it, there was a time in our world where you could just use a database for all this stuff. I mean, you guys remember back then? It was so simple. It was so easy. We just had a handful of people using dial-up modems in some case. Total aside, we were watching an old movie recently with my son. He's 11. And there was a scene where they had to dial in, and so you hear the modem sounds in the background. And we had to tell my son, that's how you used to get on the internet. And you could tell this didn't register for the 11-year-old because that was not even something he'd ever considered, right? And so this worked until our traffic grew, and then all of a sudden talking to the database becomes a struggle, and now our performance goes down because we can't talk to the database fast enough. What do we do about that? Well, let's not use the database. I know, let's store session on the server. What could possibly go wrong? Well, and that worked for a while, but even then we had issues because we had multiple instances of the server, and we'd have to figure out how to do sticky affinity, or we'd have to stash that on a durable store anyway. And of course, nowadays, well, that's out the window because we're in the cloud, and our servers are ephemeral. So you can't store it on the server because you don't know if that instance will even exist when that user comes back the next time. So how do we solve that problem in a cloud environment? Well, imagine that. We can use Redis. We can let Redis handle that for us. We can let Redis deal with session state across servers. This is just a hash. That's all it is under the covers, let's be honest. And so we can say, hey, you know what? Save these key value pairs for me. Get those values back for me. We have all sorts of queues in our world, don't we? We got this whole list of items that we need to work on, and we want to do that asynchronously so we can reduce blocking and wait times. I had a client a few weeks ago. We were walking through their architecture, and it became very clear that they had a big O of N problem because the way they had designed their system, every new thing they had to work on increased their processing time. And they were hitting the point where we can't process overnight anymore. There's not enough hours in the night for us to do this. And as you look at it, you realize, well, every one of those things is independent and could be worked on separately. So what you want is a pool of workers that goes and grabs the next available item off a queue, chews on it, and then does whatever is necessary. And that just sounds an awful lot like a list. So we can push them on, put them on at the beginning, put them on at the end, move it from one queue to another. We have all these tags in our world. I mean, so many tags, which then leads to this really difficult problem. Well, how do I find everything that has this particular tag in it? This becomes a bit of a challenge. So wouldn't it be nice if we had a nice little set of unique collections of those strings, and I can actually see, are you a member in here? Does this article have this tag or not? Then I can say, can you get me everything that, give me all the tags for this specific article? And we can use the same kind of technology to say, hey, can you recommend things like this for me? That's a really powerful thing, especially in retail these days. I mean, how many times has a product been recommended to you? You never would have found it on your own, but people who search for this also search for that, and you're like, wow, I started using this with movies because we're kind of running out of things to show my son. And so it's like, well, he likes these kind of movies. What's like this? So I'll go to a movie he's already watched and not interested in just to see what else comes up in that search. How about leaderboards? It's an interesting place where you can use a sorted set. Now, I know your first reaction to a leaderboard might be, I don't work on games. Why do I need a leaderboard? Well, here's an interesting use case. Do you have error messages? You ever curious about what like your top error message might be? How about having an error message leaderboard? That might give you some interesting insight to what's going on in your application. And that looks like a sorted set. So I can add, I can update, I can use rankings to figure out, hey, what makes sense here? I mentioned earlier that I can't just log to the file system anymore because this app instance might be gone and then I don't have my logs anymore. Well, how do I do with logging? Well, I just have to put that in a stream. Well, now I can actually use Redis for that. I can have a unified log with Redis streams. And so now I can distribute this state across my system by using that unified log. Because of course, if I'm going to do that, it needs to be durable, it needs to be ordered. And this fundamentally just acts like a master ledger. So streams help us here. I can add it, I can do arrange, give me back a set of records here. The moral of the story, guys, is this is more than just a cache. There's all sorts of solutions that we can bring to bear here. And when we're in these microservices ecosystems, and we're trying to have these stable, reliable services that we can trust, we can't just do things the way we always have in the past. We need to bring new technology to bear. Now, I've looked at technology change, quite frankly, as a feature, not a bug. This is the nature of our industry. I have no idea what we're going to be doing in 5 years. I'm pretty convinced it'll be different than what we're working on today. You know, I'll wager you that the things we're going to be doing in 5 years probably haven't even been invented yet. I think that's really exciting. I've got a golf buddy who has, for the last several years, kind of been bugging me like, hey, don't you think you should get into management? You know, you're kind of at that point in your career where you should become a manager. You know, and his experience was different than mine because he worked in, you know, as kind of a business consultant. And so he got to a point where his work was the same day in, day out. It was boring. So he got into management so he could do something different and, you know, grow staff and become a force multiplier. When was the last time you got bored? I mean, my job changes every couple of years, seemingly. And so I don't think I've ever felt that I could do my job cold. The challenge for us, honestly, is evolving along with this and understanding what these changes mean to us and how we move forward with that. But it's also important to take a step back and realize that a lot of these changes, we're just kind of redefining some things. We're renaming some things. It's the same kinds of problems we've dealt with in the past. Now, the important thing for us is being able to pick up the right tool at the right time and know when to use this particular tool to solve the problems that we're experiencing in our world. I wish you luck. Thank you so much. I appreciate your time and attention.